Hello, I'm Shahbaz Abid. This is General Physics 1, Lecture 3. In this lecture, I'm going to continue my discussion on motion in one dimension. As we discussed in the previous lecture, that when we have a constant velocity, the position versus time graph is going to be a linear graph. So let us derive an equation of motion whenever we have a constant velocity, and that equation can be used in any question which has a constant velocity criteria given to us. So the slope of the position versus time graph is known as velocity. So velocity is going to be rise over run, which is basically a slope of the position versus time graph. Rise is going to be displacement, which is final position minus initial position, and run is going to be delta t, which is final time minus the initial time. If I rearrange this equation with respect to delta x is going to be v sub x times delta t. Delta x, again we know it's final minus initial position, and delta t is final time minus the initial time. So if I substitute delta x as xf minus xi, it's going to be xf minus xi is equal to v sub x times delta t. So if I bring the xi on the other side, it will become positive xi. Most of the time we have initial time equal to 0. So we can just say that delta t is equal to the final time, and it is basically equal to t itself. So xf is equal to v sub x times t plus xi, which is identical to the equation of the line. So this equation is actually representing the equation of this graph. Let us see example 1. How long will it take for the car moving at a constant velocity of 30 meters per second to reach a truck that is 150 meters ahead and moving at 20 meters per second? The very first thing we need to do in this problem is to locate the origin. So I am going to locate the origin where the car is located at this instant. So based on this origin location, the given information we have is the car has an initial position equals to 0 because the car is located at the origin, and the velocity of the car is equal to 30 meters per second positive because it is moving in the positive x direction. Whereas truck is having an initial position equal to 150 meters, and the velocity of the truck is equal to 20 meters per second positive value because it is moving in the positive x direction. Since it is a constant velocity problem, we have to use this equation to solve this problem. The trick behind this problem is that when car and truck meet, the car is going to reach a truck at the same position, and the time is going to be same as well. So in other words, the final position of the car is equal to the final position of the truck. So the final position of the car is going to be velocity of the car times t, which is unknown, plus initial position of the car. So it's going to be 30 times t plus 0 equal to final position of the truck, which is going to be velocity of the truck times t plus initial position of the truck. So it's going to be 20 times t plus 150. So the only unknown we have is t. So we can solve for the t, and it's going to be equal to 15 seconds. So car will take 15 seconds to reach a truck. Let us see example 2. Two boys moving directly towards each other. They are initially 100 meters apart. One walks at a constant velocity of 1 meters per second, while the other walks at a constant velocity of 1.5 meters per second, but begins moving 2 seconds later. They meet at a shop. Determine the time in seconds when they both meet each other. So again, in this problem we have to locate the origin. So let us call this boy to be B1 and let us call this boy to be B2. So I'm going to locate an origin where the B1 is located at this instant. So based on this origin location, the given information we have is the initial position of B1 is equal to 0 because it is at the origin. The velocity of B1 is equal to 1 meter per second positive value because it is moving in the positive x direction. Whereas B2 has an initial position equals to 100 meters, and the velocity of B2 is equal to negative 1.5 meters per second because it is moving in the negative x direction. There is another trick in this problem is that there is a delay between B1 and B2. of 2 seconds. So considering this, we have to use delta t in the equation of motion. So it's going to be xf is equal to v times delta t plus xi. So the b2 is going to have an initial time equal to 2 seconds. So again, the final position of b1 is equal to the final position of b2. So it's going to be velocity of b1, which is 1, times t plus 0 is equal to negative 1.5 velocity times final time minus the initial time of b2 plus 100, which is the initial position. So solving this problem, we are going to get the time equal to 41.2 seconds. Let's see example 3. Two pedestrians left at the same time from two villages that were 27 kilometers apart and walked towards each other, eventually meeting after 3 hours. The first individual walked at a constant velocity of 4 kilometers per hour. What was the velocity in meter per second at which the second individual walked? So again, in this problem we have to locate the origin. So first of all, let us say this pedestrian to be P1 and let us say this pedestrian to be P2. So I'm going to locate the origin at P1. So based on this origin location, the given information we have is P1 is having an initial position equal to 0 because it is at the origin. The velocity of P1 is equal to 4 kilometers per hour, positive value because it is moving in the positive x direction. Whereas initial position of P2 is equal to 27 kilometers, positive value because it is on the right side of the origin, which means on the positive x axis, whereas the velocity of P2 is unknown. First of all, we have to convert all the lengths to be in meters and all the time to be in seconds. So the velocity of P1 was 4 kilometers per hour. In my lecture 1 video, I have given a shortcut that if you want to convert kilometer per hour to meter per second, divide that number by 3.6, you will get the answer in meter per second. So the answer is going to be in fraction as 1 over 0.9 meter per second to be accurate. Whereas the time was 3 hours. So in order to convert hours to seconds, you have to multiply with 3600, so it's going to be 10,800 seconds. The initial position of P2 was in kilometers, so to convert kilometers to meters, you have to multiply with the 1000 conversion factor, so it's going to give me 27,000 meters. The same criteria here as well, that the final position of P1 is going to be equal to the final position of P2. They are going to meet at the same position at the same time. So velocity of P1 times t plus initial position of P1 is equal to velocity of P2 times t plus initial position of P2. So the only unknown we have here is the velocity. So the velocity of P1 was moving in the positive x direction, and they are walking towards each other, which means that the velocity of P2 will be in the negative x direction. So I have put a negative here already and it's still unknown. The value is still unknown. So substituting all the values, we will get the velocity of P2 to be equal to 1.39 meter per second. We got a positive value because our direction assumption was correct. But if just in case you put this velocity as positive velocity, you are going to get it as negative, which means what, that your assumed direction was wrong. You assumed that it is in the positive x direction, but you got it as a negative, which means it's in the negative x direction. So it doesn't matter that if you get positive or negative, the magnitude is equal to 1.39 meter per second. My assumption was it is moving in the negative x direction, I got a positive answer. But if you assume that it's a positive velocity times P2, you will get a negative value of velocity P2, which means it's in the negative x direction. Thank you, and I will see you in the next lecture.